Simon Ohm was a German physicist and a mathematician. He discovered the law named after him, which states that a current flow through a conductor is directly proportional to the potential difference, or the voltage, and inversely proportional to the resistance. André-Marie Ampère, a French mathematician and physicist. An ampere, or amp, is the amount of current produced by the force of 1 volt acting through a resistance of 1 ohm. James Watt was a Scottish inventor, a mechanical engineer, and a chemist. He developed the concept of horsepower and the unit of power, which was named after him, the watt. So in understanding Ohm's law, let's consider some of the terms that we use. Voltage is the force that makes electricity move through a circuit. The current is how much electricity is flowing through the circuit. The resistance is something that resists the flow of electricity through the circuit. And the watt is a measurement of the rate of energy transfer. This is what is called the equation wheel. It shows the many different equations that are used to figure different values of an electrical circuit. In the previous slide, we saw the equation wheel that shows all the different equations that can be used when working on electrical circuits. In this slide, we see the simplified wheel that we use quite often in daily work in HVAC. The wheel on the left is the E over IR, which is volts, and current, which is the amp draw, and the resistance, which is our ohms reading. The wheel on the right shows watts, which is power, and then your current, amps, and your voltage, E. By covering over the value that you want to find, we see the equation that we can use. So in this particular example, if we want to find the voltage, we cover that value, and then we take our amps and divide it by our ohms or resistance to get our voltage draw. So by covering over the value that you want to find, it tells you whether you need to divide or multiply the value to get the answer. Here we see a practical example of Ohm's law. You may have seen this question if you have recently taken the NATE certification exam. The question states, electrical resistance heaters give off 3.42 BTUs per watt. How much heat will an electric resistance space heater give off if it draws 20 amps at 230 volts? And then you have answers A, B, C, and D for this question. In order to find the answer, you need to use Ohm's law and take amps to watts, which is watts equals amps times volts. So in this example, our voltage is 230. Our amp draw is 20 amps, and we multiply those two to get 4,600 watts. Then we times that times the 3.42 BTU per watt, which gives us the answer of 15,732 BTUs. So this resistance space heater will give off 15,730 BTUs. In this example, we want to find the voltage drop across each heater element in this circuit. Ohm's law states that voltage equals current times the resistance. So the equation that we are going to use is E equals I times R. First, we must find the total resistance in the circuit. Rule 4 tells us that total resistance in a series circuit can be found by adding all the resistances together. So we add resistance 1 plus resistance 2 plus resistance 3, which will give us the total resistance of the circuit. So our resistance values are 10 plus 20 plus 30, which equals 60 ohms. Second, we must determine the current flow in the circuit. The Ohm's law formula for that is I equals E divided by R. I is 120 volts divided by 60 ohms equals 2. Now that we have the total current, we can find the voltage drop across each resistance by using Ohm's law formula E equals I times R. So by using that formula, we find that heater number 1 is 2 times 10, shows us that 20 volts are dropped across heater 1. 2 times 20 is 40 volts dropped across heater 2. And 2 times 60 is 60 volts dropped across heater 3. Lastly, when we add the voltage drops, Rule 5 applies. 20 plus 40 plus 60 equals our 120 volts. And Rule 5 states that the sum of the voltage drops equals the source voltage.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.